All right, so I guess in that case, good afternoon, everyone. Thank you for joining us on this talk on how to build a social network in just under 4 weeks with Serverless and GraphQL. So recently, I worked on a client project where I built a backend for a new social network that lets you, mostly university students, register your sporting interests and find other people to do sports with. You can arrange activities like basketball match and have a group chat, or you can message each other directly and arrange doing sports together. The client is a privately funded, bootstrapped startup, so there's a lot of constraints on money and therefore development time, and they also need to have something in place before the new semesters start. So that was going to be in September. Hopefully that's still going to be the case. And so from the get-go, I had some clear goals to work with to help me drive my technology decisions and what approaches I should take. We want to maximize the speed of development, as the client needs to get the app out quickly and can't afford a long development cycle. But at the same time, they need something that can scale to have millions of users if it takes off. They already have agreement with the local universities in Belgium to roll it out to tens of thousands of students right away. And this is especially important because the first version of the app they built with PHP and running on 2 servers was a disaster, and it crashed on launch day. So we can't repeat the same mistake. The system needs to have a minimum upkeep. Again, the client doesn't have the funds to hire a full-time team to look after this. So the system pretty much needs to run itself and not fall under. So it also needs to be cost efficient as well, as we scale to hundreds of thousands, maybe even millions of users. The project was put together with a very small team of 3 engineers, including myself, where I was working part-time, probably averaging 2 to 3 days a week for a couple of weeks. And I was also juggling responsibilities with other clients as well. And we didn't just build the mobile app, we also built a CMS for the app as well, which will be used by the founders to onboard new universities and for university admins to sort of manage the list of sports you have and sort of manage the list of coaches. You can have those sporting activities. So I'm going to sort of show you I'm not going to show you the full architecture, but here are a few of the key components of the architecture, where we have CloudFront and S3 for the image assets, and for authentication we use the Cognito. There's one Cognito user pool for the mobile app, and then there's another for the CMS as well. And the backend is built using GraphQL, using AppSync. Again, one for the mobile app and then one for the CMS. And they each have resolvers that point to DynamoDB tables for simple get, put, and query operations. For anything more complicated than that, I will have a Lambda function resolver, and that function might also do more complex stuff against the DynamoDB table. You can also use pipeline resolvers instead of having Lambda for a lot of these things, but I think it's easier for me to do it with Lambda, and also easier for me to hand it off to somebody else later, because it's easier to write some Node.js code than to write, say, some VTL. And we also use Algolia for search, and Algolia is probably the closest thing you will have to a serverless Elasticsearch. To get the data into Algolia indices, I use DynamoDB streams to trigger Lambda functions to synchronize the data changes to Algolia. So whenever a user creates or updates their profile, or they start a new sporting activity in the app, I will forward them to Algolia through a Lambda function. And I also capture those BI events from those different Lambda functions as well. And I use a Firehose delivery stream to buffer and batch them into files in S3, and so that we can then run business intelligence analytics queries against them using Amazon Athena. Again, this is not the architecture diagram, but it's just a summary of the different services I used and how they kind of fit together from a high level. So moving a level up, we have multiple AWS accounts, which is a good security practice for limiting the blast radius of any security breach. And it also gives you consolidated billing and the billing reports across all the different accounts. I used the AWS organization for managing these accounts, and I had the 4 independent organization units for dev, staging, production, as well as an org unit for accounts that manage shared resources. For example, there's a shared US users' accounts for single sign-on, and a shared account for collecting all the audit information, such as CloudTrail logs. And at the organization root, I have a couple of service control policies or SCPs, for example, to deny access to all services outside of EU West 1, because I know that's the only region that we're going to use right now. And also we got SCPs to disable your ability to stop a CloudTrail collection or to delete any of the collected logs that we have in CloudTrail bucket. Again, remember, all of this was done by one person working part-time for a couple of weeks, and it's only possible because I could stand on the shoulders of giants, and really all the hard work is done by AWS and other service teams, and I can rely on good tools like the Serverless framework to help me manage and deploy my application. So my name is Yan Cui. I'm an AWS Serverless hero, and I've been running production workload on AWS for more than 10 years now. The last couple of years, I've focused mostly on serverless technologies, including migrating a social network to pretty much run entirely on serverless, and that was about 2016 when I did that. You can read about this, that particular migration story using the link down below. Nowadays, I spend half my time working with Lumigo as a developer advocate, and the Lumigo is a troubleshooting platform for serverless applications where you have one place to find all of your distributed traces with the logs for the relevant functions side by side, and you can also quickly explore what other information, what else is going on in your environment, and you can also tap into each of the functions and see the different states, every single HTTP request you're making, what's the request response, so they can help you debug problems really easily. The other half of my time, I work as an independent consultant, where I work with many customers all around the world to help them go faster for less by adopting serverless technologies. In my spare time, I've done a couple of books for Manning, and also did a video course for them as well. And I've also self-published a couple of video courses since then. And nowadays, I also do a weekly podcast where I speak with people that are building serverless product or serverless using serverless technologies in production and building products with them. So I'm sure most of you by now have heard about GraphQL already, so I'm not going to take too much of your time to explain what GraphQL is. Basically, GraphQL has a schema language that lets you define the data types and operations that you support, including queries for fetching data and the mutations for mutating them. The client is going to send a query or a mutation to a GraphQL server, and Apollo is probably the most popular implementation of a GraphQL server, and that the server is going to validate the request against the schema, it's going to pass them, and then in turn it's going to fetch data from different data sources and then stitch them together in the format the client has asked for. So think of it as your backend for frontend, except you don't have to write bespoke endpoints every single time the client wants another piece of data or wants them in a slightly different shape. And as for AWS AppSync, it's basically a managed GraphQL server which lets you map those queries and mutation operations as well as the data types that you have in your schema to different data sources in your AWS account. And it supports DynamoDB, Lambda functions, Aurora database, Elasticsearch, as well as just raw HTTP endpoints out of the box. For example, as a logged in user, I need to fetch my profile, and in my query, I can fetch everything I need, including my ID, my first name, my last name and gender, and what sports I'm interested in. So these are then mapped to a profile table in DynamoDB, so AppSync would then fetch my profile using the authenticated user's ID that Cognito has provided. But wait, the list of sports in the profile, it only contains the ID for the sport, because I don't want to have to change the display name and image URL for those sports. So we don't want to bake them into every single user's profile. So we're just going to have an ID in those user profiles. So that means we need to expand those when the user asks for the information about their sports, and fetch the image URL here and the display name for every sport that I'm interested in. So within GraphQL, this is called a nested resolver. In this case, AppSync can then fetch those information from another table, a sport table in DynamoDB. So we're all good here. There's no need for the client to send two separate API requests So it saves us some additional round trip here as well. As for my activities, since I have many activities, so when I fetch my profile, I just need the first page of it. And for my next set of activities, that's probably all I'm going to need. So now what I'm going to be doing for the next couple of weeks. So AppSync runs a query against the activities table where the data is stored with my user ID as the hash key and the timestamp of the activity as my range key. So we can easily get pages of activities in descending order based on the timestamp. And since other people might ask to join my basketball match for next week, for example, I also want to fetch any outstanding requests to join my activities as well. Again, we only store the user ID in these requests. And to display this request in the UI, we are going to have to expand this into those users' public profiles. So we can get their name and profile image and so on and so forth. And so we have another nested resolver that also have to get profiles from the profile table. So as you can see, this is very flexible. The client can basically ask for any information they need within a single query. But you can probably also sense the danger here as well, that the client might just end up asking for way more information than you need, and you can have those really deeply nested queries that can start to impact your performance and your cost. So luckily, you can mitigate some of this by enabling caching on AppSync, which lets you sort of cache response for specific resolvers, and you can also adjust the caching, the TTL for the cache for each of the resolvers as well. And to prevent the further nesting and to prevent sort of leaking personal information like date of birth, there's a separate data type for your profile, which only you can fetch, and your public profile, which other people will be able to load when they find you in the app, maybe through a search or maybe through activities that you are part of. And there's also a much flatter structure when it comes to your public profile, so that there's less need for nesting. So that one query returns all the information I need for my profile in the app. And when you see other people's profile, you're looking at the data that's available only through their public profile. So I can't accidentally return your someone else's date of birth to me, because those information is only available for their personal profile, which they can load when they open the app. So AppSync itself is very scalable. The GraphQL subscriptions implementation can support millions of connected clients, and your AppSync API is deployed to multiple availability zones out of the box, which gives you a really good baseline for resilience as well. And you can pay for, and you only pay for what you use at $4 per million operations. And as I mentioned earlier, it's got built-in support for caching, which does charge you extra, especially essentially you'll be paying for uptime for a memcached node. It also has support for monitoring with CloudWatch and CloudWatch logs, where you get high-level metrics like the number of API requests, error count, and latency, which is great. But unfortunately, these are all aggregated, so for the whole API, so it's difficult for you to tell which of the resolvers is having a problem, because maybe just one DynamoDB table that's having issues with latency or is getting throttled, because a single query can ultimately involve many resolvers, so you can make many queries against different tables all within one operation. So what you need to do in this case is to enable logging, which can give you more information about what's actually going on, so you can at least narrow it down to specific requests that took a long time, and then find out for each of the resolvers which resolver is the culprit here. For performance issues like that, it's even better to enable X-ray, which really shines a light on what's going on under the hood and show you where the time is taken. And you can see that this single query has resulted in quite a few DynamoDB table calls behind the scenes. And the X-ray also shows you a service map as well, so you can get a high-level view of which services that your AppSync API is talking to, and their overall health and the average latency and so on. And it gives me all of this, and I don't have to manage any servers, which is amazing. So in general, everything has worked as advertised, but I did run into a couple of really small niggling issues. For example, there's an issue with documentation around how to handle conditional check errors with DynamoDB resolvers. the documentation was just wrong. I've raised it with the AppSync team, so they're looking into it. So in the meantime, if you need to know what to do, I've got a blog post here, and also wasn't clear on how to skip nullable fields when you have a nested resolver. So again, I'll roll a blog post on how you can do that. You might have also noticed that I've got quite a few DynamoDB tables here. I think at the end I've had about 15 tables. And if you've been following what's happening in the DynamoDB space, you might have heard about this whole thing around the single table designs and wondering why I didn't condense some of these tables into single tables, which offers oftentimes the best performance, scalability, and probably cost as well. But for this app, we don't need to optimize for the best performance and scalability, and the multi-table design will be sufficient, at least for the foreseeable future. And the thing with single table design is that it is much more complex and requires a much thorough understanding of how DynamoDB works, especially in terms of global secondary indexes. Now, I don't remember who said this, but I do prefer to design my systems as if it's going to be run by idiots, because one day it will be, and most of the time the idiot is yourself in the couple of months' time. And in a world where most developers are familiar with single table designs, then I would be very happy to use single table designs for all the technical benefits I just mentioned. But until then, I need to do right for the client and build a solution that somebody else can easily pick up and carry on. But as a member of the AWS community, I do want to help create more awareness around the single table designs. So if it's something that you are interested in and want to learn more, please check out this talk by Rick Houlihan from reInvent 2019, and also check out Alex Debris' DynamoDB book, which will really help you get the most out of DynamoDB. It includes many advanced modeling patterns as well as tips and tricks. So in terms of authentication, as I mentioned earlier, we use a Cognito user pool, and I set up identity federation so users can sign in using Facebook and Apple as well. And on the client side, we use the Amplify.js library to integrate with Cognito, which really makes things quite simple as far as authentication logic is concerned. It does all of these things for you, including refreshing your tokens when they expire. However, I didn't use the Amplify CLI to create and configure the Cognito user pools. Instead, I did them by hand using CloudFormation because, well, I know how to do it. And if anything, I kind of want to know what's been configured. And with the Amplify CLI, with evolving so quickly, I've had quite a few people tell me that they've had problems with breaking changes, and it's just not something that I want to deal with on a client project. Maybe if it's something that I'm running myself and responsible for running it in the future, then something that I'll consider. But for this particular project, I didn't think it was the right fit for us. And I do think that Amplify CLI is really good for quickly bootstrapping a new app, maybe as a proof of concept, especially for a team that doesn't have a lot of experience with AWS and with Cognito in particular. It helps you get something going quickly and give you some good defaults. But I also heard that it had trouble coping with some changes, and a few people told me that they've had to delete the entire stack when it got stuck and they can't deploy some changes. Again, probably due to the fact that it's still quite a young tool and still maturing, but it's just not something that I wanted to deal with on this client project because we had a very tight deadline to deliver something. So Amplify can also provision and configure DynamoDB tables as well as AppSync resolver for you as well, but I don't agree with some of the decisions that it takes. For example, it defaults using scan for list operations, and in this particular case, the DynamoDB schema and the access patterns are quite important here, with potentially huge scalability and cost implications. So I want to have tighter controls around that access pattern, and I need to understand my access patterns pretty intimately and how I configure my resolvers. And don't forget that we also built the CMS as well, which also uses Amplify.js to authenticate users to the CMS Cognito user pool. And as an admin for the app, which would basically be the two founders, they can onboard the new universities, they can configure the default list of sports that you see in the app. But when you onboard a new university, you also need to invite an admin person from the university to the CMS as well. So we generate a temporary password for you when we register a user in the user pool for the admin user for the university, which is all done by a Lambda function behind the CMS AppSync. The user is then able to log into the CMS. They'll be asked to update their password on the first sign in, which is all done by Cognito anyway. And the CMS user we created for them will be added to the university group to identify them as a university admin. So we use a custom attribute to tell us which university that they are the admin person for, which is then passed to us by Cognito when the user talks to the CMS AppSync API resolvers. So at no point does the client pass the university ID to the backend to say, hey, I'm the admin for this university, let me access the data. No, it's always based on your identity. And when you are the admin for university, you have different options in the CMS, and it's limited to just your university. The nice thing with AppSync is that you can implement this group-based authentication using Cognito groups out of the box. So if you are an admin, you'll be able to get university details by name, and you can edit the sport that we have in the app as well. But if you are the admin for a particular university, then you can only fetch and edit information about your university. And if we don't specify any specific options, then any logged in user can perform some of these options, like getting an upload URL for images, assets, and so on. So moving closer to the code, I use the Serverless framework to help me package and deploy the application. It's mature, it's got a great community around it, and it's also very, very extensible through a whole host of plugins from the community. And we're going to see a couple of them in a minute. So I was already very familiar with the Serverless framework. It's my go-to option for a couple of years now, and I'm very proficient with it. And in this case, I've got one repo for the whole backend. Everything is configured in one server.yaml and is deployed as one CloudFormation stack. So resource reference and all that was very straightforward, even as the project grew. And to deploy, I had just one command to run. And to make it easy for me to configure all of these resolvers I had with AppSync, I'm super happy that this Serverless AppSync plugin, which makes it really, really easy for me. So as I mentioned, I've got two AppSync APIs, one for the app and then one for the CMS. So I broke these two into their own files so that things are a bit more manageable as they grew. And each of these files is going to look something like this, where I'm going to hook it up to the right Cognito user pool. I'm going to configure logging in production. We don't want to log everything because it's just going to generate so much logs to CloudWatch, and it's going to have a cost associated with that as well. And then I'm going to configure my resolvers and data sources in the same file. For many of these resolvers, we'll be going straight from AppSync to DynamoDB directly without going through Lambda. So the request and response templates have to be written in the Apache VTO, which is the same templating language the API Gateway uses as well. So I'm pretty familiar with it already, and honestly, the official documentation does a pretty good job and gives you a bunch of examples that you can just follow. So most of them look quite similar anyway. And as the project grew, I pretty quickly hit the 200 resources limit on CloudFormation. Since I also try to follow the principle of least privilege and have a different IAM role for every single Lambda function. So it didn't take me very long to get up to 200 resources in this case. Luckily, there's also the split stacks plugin for the Serverless framework, which can split your one stack into multiple stacks by splitting some resources into a nested stack. And the great thing here is that it also lets you control the splitting logic yourself, which was very, very handy here, because remember, I've got two AppSync APIs, and each of them has got its own Cognito user pool and its own set of resolvers, and they're pretty much independent of each other. So I wanted to split them by the AppSync API itself. So in this case, I had a total of about 350 different resources, whereby all the shared resources like the DynamoDB tables, S3 bucket, and some of the Lambda functions that are not part of the AppSync API, they are in one stack. Things like the Lambda functions that are processing and synchronize data in the background to Algolia, for example. So they're all in the same parent or root stack. And then all the functions, resolvers, and the corresponding IAM roles that are all split into nested stacks for the individual AppSync APIs. And as you can see, there's quite a few more things in the app nested stack compared to the CMS nested stack. The great thing about all of this is that I can still reference DynamoDB tables and other resources in the parent stack as if they're in the same stack, because a plugin passes them around as parameters to the nested stack, so there's no code required, no code change required when I had to split up the stack from one into multiple nested stacks. Which brings me to CI/CD. And since the whole code base was in GitLab, I just decided to use GitLab CI/CD, which kind of works the same as all the other stuff, really. And the one technique I've employed in most of my projects is to install the serverless framework as a dev dependency, which means I don't have actual dependencies on a CI server, and I can just add a helper script to my package.json, and when it came to deploying from CI, is literally a two-step thing: to run npm CI to restore the exact version of my dependencies as they were in the package.json file, and then run npm run serverless deploy to trigger deployment using the version of a server framework that's been installed in the project. But we still have to manage the AWS credentials to run deployments, right? And a pretty common question I get is, well, how do I secure my CI/CD pipeline itself? And so far, the best approach I've seen is, well, in the case where you have to put some AWS credentials into a CI tool somewhere, and assuming that you have multiple AWS accounts, say one for every environment, then you have a dedicated ops account, for example, where you will run your ops or security monitoring tools there, and you will set up a CI user which has no local permissions in the account, basically a flat out deny on all actions in the ops account. So in the event that the credentials were somehow compromised and leaked, the attacker won't be able to do anything with those credentials in the ops account. And then in each of the AWS accounts where you want to deploy stuff into, these are your destination accounts. You will have a deploy role which this CI user is allowed to assume. And each of these deploy roles will have an entity trust relationship to this particular CI user in the ops account, so that they can only ever be assumed by this user and this user only. So even if, again, the credentials for this CI user is leaked, then the attacker will not be able to do anything in the ops account. And in order to do anything, they have to know the account ID and the role name for each of the target roles that they need to assume role into. So this way, you can have a very permissive deploy roles and still be safe in your CI pipeline, because they can only be assumed by the CI user, which on its own has no permissions whatsoever in its own account. But if you want to add another layer of protection, then consider using attribute-based access control, or ABAC, where you can further limit access to resources by tags. But for now, many of the services that we use just don't support it yet, including Lambda, which is again the reason why I didn't use it here. And when it comes to testing, one of the challenges with using something like AppSync is that it's a bit of a black box. So, how do you test it locally? One of the, there are tools that simulate AppSync locally, but I generally don't bother with them, as they don't cover everything, including IAM policies. And honestly, those VTL templates are so simple, they just work. Where it tends to go wrong is in my Lambda functions, where I tend to do more complex logic anyway. So for those functions, I like to test my integration with other services like Algolia or DynamoDB by executing the function locally, but talking to the real DynamoDB tables or the real Algolia index. I don't tend to use mocks or stubs here, or simulate them locally with things like local stack or DynamoDB local. They take too long to get them working properly, and they're also a bit brittle as well. It's just easier to provision the tables and then use them in my integration tests. And then I also have end-to-end testing that runs user stories like create a profile, do a search, and then join another user's activity and so on. And I run this against a deployed GraphQL endpoint. So this will be always run. Always after the deployment. And if you've got any failed end-to-end tests, then great, use them as a valuable rehearsal for how to debug real problems in production. If it's difficult, then guess what's going to happen when you do have a problem once the system is live. Use that as a signal that you need to improve your logging and how you're monitoring systems and enable X-ray tracing and so on. If you struggle to debug problems in a controlled environment like your end-to-end testing, then you're really going to have a bigger problem when this thing is running in the wild. So don't optimize for your comfort with these local simulators. It's a false sense of security. And finally, let's talk about the AWS organization setup itself. So I've mentioned I had a couple of org units and different AWS accounts, and I don't want to manage them by hand. Instead, I want to have infrastructure as code for all of these things as well. So fortunately, there's this tool called the org formation, which gives me exactly that and lets me provision and manage my entire AWS organization with infrastructure as code using this YAML-like syntax, which is very similar to CloudFormation itself. And it makes it easy for me to template my landing zones, which is basically what the sort of set of base infrastructure that should be provisioned to every new account. Things like KMS encryption keys, VPCs, and things like that. So in this case, I was able to declare a master AWS account as the root for my entire organization. Again, it's all done in code using a syntax that's very similar to CloudFormation. And I'm able to provision a new account and set up budget alarms with just a few lines of code. And I can attach this account to organization units, which I can also, again, have them be captured in code. And I can also configure service control policies. For example, here, I know the only region I'm going to use is EUS1. So I can set up a service control policy that denies all actions against regions other than EUS1 and apply this policy to the organization at the root so that it's applied to all the accounts I have in my AWS organization. And I can also configure my password policy for AWS users and use this policy in all of my accounts as well. Again, this all can be captured as code. And whenever I make any changes to my organization, I just have to run this one command to update my entire AWS organization, all the different accounts, provision new accounts. And to configure my landing zone, I can configure what is called a task, where I basically specify a CloudFormation template and provide bindings to my organization, which basically says which resources from the template should be created in which AWS accounts by binding the resources to org units or specific accounts with specific tags. So here's an example of one of my templates where I have got just like a normal CloudFormation resource for an IAM user, but I can bind this resource to a subset of accounts in the organization using this organization binding that says please only bind this to a particular set of accounts in the org units. And then down below, I can iterate through all the AWS accounts that are provided by the binding. And don't worry if the mechanics of how this works looks a bit alien to you. Once you spend a bit of time with org formation, it will start to make a lot more sense. And then to update all of my landing zones for all my accounts and different regions, I just run another single command to update all the different landing zones I have. It's a really, really powerful tool. So I really recommend you go and check it out afterwards. It's available from GitHub and is maintained by MoneyU, which is a bank here in the Netherlands. And that's kind of the three main tools I've used in this project: the server framework for deployment automation, AppSync for the manage the GraphQL server layer, and org formation for automation around the entire AWS organization and all the different accounts I have. And if you go back to the goals I started off with, in terms of speed, getting everything done within 4 weeks is pretty good going, considering the amount of stuff involved, and I was working part-time on this on my own. So speed of development, check. AppSync can scale to support millions of users, absolutely no problem, so check again there. And I have zero EC2 servers to manage, so no networking, no VPCs, and none of that. So minimum upkeep, check. With AppSync, Lambda, and DynamoDB, our entire stack is pay-as-you-go, and the cost per million operations is just a few dollars. So the projected cost for this is when we go live with tens of thousands of users, will still be very small, even if everyone uses the app a fair bit. So being cost efficient, check as well. And that kind of brings me to the end of this talk, and that's all I've got. So thank you guys so much for your time and attention. And as I mentioned earlier, I work mostly as an independent consultant. So you can go to theburningman.com to see how we can work together and check out my services. And if you want to learn more about Lambda and some of the best practices that you should follow for performance, scalability, and resilience, then check out my new video course, lambdabestpractice.com. And with that, thank you guys so much for your time, and stay safe. And I guess we have some time to answer some questions if you've got any.